Welcome to the deep dive. Today, we're tackling one of those huge historical debates, the kind you get into late at night. What is the single most important invention ever?
It's a fantastic question.
Mm.
And our sources for this go way beyond just, a simple popularity contest.
Yeah.
We've got data from expert surveys, including one on the greatest British innovations, plus these deep case studies of tech that didn't just improve things, they completely redefined human life itself.
And that's really our mission here. We're not just trying to make some kind of leaderboard. The real deep dive is to look at not just what was invented, but the messy, contradictory, and often spectacular fallout that came after.
It's like every big breakthrough solves one problem, but, creates three new ones down the line.
Exactly. Okay, so let's unpack this. If we're looking for an invention that just shattered a fundamental human limit, I think we have to start with how ideas spread. And that takes us to Johannes Gutenberg and his printing press in the mid-1400s.
Right.
To really get its power, you have to imagine the world before, say, 1455.
Exactly. Before Gutenberg, knowledge was, well, it was a scarce good. A single book could take an expert scribe months, sometimes even years, to copy by hand.
Wow.
And it was incredibly expensive. Plus, and this is crucial, every single copy was prone to human error. So access to read information was basically limited to the nobility, the very wealthy, and the church.
So what was Gutenberg's specific genius here? Because presses already existed, right, for things like wine?
Yeah, that's the key. It was synthesis, not a brand new invention out of thin air. He was a master systems integrator. His big breakthrough was taking that screw press, the kind for grapes or olives, and adapting it for the heavy force you need for printing.
Okay.
But the real game changer was combining that with molded metal typesetting and the right kind of ink.
The ink, that feels like such a small detail.
But it was absolutely vital. Scribes used this thin, watery ink. If you put that on metal type, it would just bleed everywhere, a total mess.
I see.
Gutenberg had to develop a thick, oil-based ink that would stick to the metal just right. So that combination, the press, the type, the ink, it created a speed revolution. The sources show that by the end of the 15th century, something like 8 million religious books were printed.
8 million?
Yeah, it's about 180 times what a single scribe could produce.
And this is where it gets really interesting. That speed, it didn't just mean faster books. It lit the fuse on a social earthquake, the Protestant Reformation.
Absolutely. Martin Luther's whole challenge to the Catholic Church's authority, especially on things like selling indulgences, it hinged entirely on Gutenberg's invention.
So how fast did it actually spread?
The numbers are just staggering. Luther's 95 Theses were translated from Latin into German, printed, and then they just flooded across Europe. Between 1517 and 1520 alone, we're talking about 300,000 copies in circulation.
300,000. That is an unbelievable speed for an age with no mass communication at all. It basically let an ordinary person read these ideas for themselves and challenge authority in a way that was, well, it was just impossible before.
And that ability to accelerate knowledge, it just lays the groundwork for everything that comes after, all the way up to the digital age. I mean, when experts rank modern innovations, many point right back to the theory of computing.
Alan Turing's universal machine.
Voted the greatest British innovation of the 20th century.
Yeah. But the theory is only half of it, isn't it? I mean, the practical application is what we all live with now.
Precisely. And some argue the real successor to the printing press is this concept they call distributed networked intelligence, or DNI.
Which is basically the internet.
Basically, it's the internet. It's our collective computer brain. Information isn't just printed in one place anymore. It's shared, it's updated, it's built on, globally and instantly.
So if the printing press broke the constraint on ideas, the next logical step for humanity was to tackle the biggest constraint of all, just staying alive, food security.
And that brings us to an invention many, many sources cite as the most impactful discovery of the 20th century, maybe of all time, the Haber-Bosch process.
This is a chemical process that I think most people have never even heard of, but it is responsible for keeping billions of us alive. So what does it actually do?
Okay, so before this process, all of our agriculture depended on naturally occurring nitrogen. Things like huge deposits of bird droppings, guano mostly from Peru, or minerals like chili and saltpeter.
So wait, global food production was basically tied to the geopolitical control of bird poop?
Essentially, yes. I mean, the air is 78% nitrogen, but plants can't use it. It's inert. Fritz Haber in 1908 figured out how to fix it. He took nitrogen from the air, reacted it with hydrogen using an iron catalyst under just insane pressures and temperatures,
Yeah.
and created ammonia.
Which is the basis for fertilizer.
Exactly. It was revolutionary. Haber got the Nobel in 1918. His partner, Carl Bosch, he got one in 1931 for figuring out the massive engineering challenge of actually scaling it up for industrial production.
The sources say this process basically solved the Malthusian problem. For anyone listening, maybe just refresh us on what that was and why this was such a huge deal.
Right. So Thomas Malthus argued that humanity was basically doomed. Population grows geometrically, it doubles, then doubles again, but our food supply only grows arithmetically, just adding a bit more each time.
So you inevitably get famine, war, disaster.
Yes. It was seen as this iron law of nature. The Haber-Bosch process just completely broke that law.
It literally turned air into food.
Into fertilizer, yeah, which massively boosted crop yields. And the result was this explosive upward curve in global population that kicks off right around the 1930s.
What kind of scale are we talking about?
By 2008, studies showed the process was directly responsible for feeding about 48% of the world's population. It doubled the carrying capacity of the planet. The number of people you could support per hectare of land went from 1.9 to 4.3 in 100 years. That underpins our entire modern world.
It's just astonishing. Nearly half the people alive today are here because of this one process. But you mentioned the contradictory consequences, and with this one, the dark side is completely inseparable from the invention itself.
Absolutely. Haber's second sort of unspoken motivation was military. Reactive nitrogen isn't just the key to fertilizer, it's the key to explosives.
And when did that become a critical factor?
Almost immediately. In World War I, the Allies set up a naval blockade to cut off Germany's supply of that Chilean saltpeter. If Germany hadn't been able to make ammonia themselves with Haber-Bosch, the war would have been over years earlier. It literally fueled their war machine.
And the numbers in the source are they're hard to comprehend. Something like 100 to 150 million deaths in 20th century conflicts are linked to this process. Was this something the inventors knew from the start? Or was it a purely scientific venture that got, hijacked?
Oh, Haber definitely understood the implications. He was personally involved in developing chemical weapons for Germany. So that dual-use nature feeding people and making bombs, it was baked in from the very beginning. It's the ultimate example of a life-saving invention also being an engine of mass death.
And that's not even getting into the environmental fallout, which is still happening right now.
Still happening.
Oh.
The core problem is just inefficiency. When you put nitrogen fertilizer on a field, only a tiny fraction actually ends up in the food that humans eat.
How bad is it?
The sources say it's staggeringly low. Globally, only about 17% of that fertilizer nitrogen makes it all the way into human consumption.
So the other 83% is just washing away?
It's creating an environmental cascade. It runs off into rivers, causes these massive algae blooms that choke all the aquatic life. It releases nitrous oxide, which is a really potent greenhouse gas. And it leads to huge biodiversity loss. We basically solved one crisis, the food crisis, but we created a massive ecological one.
So if Haber-Bosch showed us the sheer scale of global consequence, our next breakthrough, penicillin, really shows how fast that cycle of invention and fallout started to accelerate in the 20th century.
Right. This is that classic story of genius meets pure luck. Alexander Fleming's famous lucky accident in 1928, seeing that penicillium mold killing bacteria on a petri dish.
But that was just the discovery, right? Not the usable drug.
Exactly. The real heavy lifting, the purification and scaling, that didn't happen until a decade later with the Oxford team Florey, Chain, and Heatley.
And they were working on this during World War II, which meant they had to improvise like crazy. I love this detail in the source material. They were so desperate for containers, they were using old bedpans and custom-made ceramic pots just to grow enough fungus.
It's incredible. A truly heroic effort born out of wartime necessity. And that effort meant it could be mass-produced just in time. By D-Day in 1944, there were enough supplies for all the Allied troops. It saved countless lives and kicked off the entire antibiotic era.
But what's so fascinating here is how quickly the dark side appeared. Fleming himself, he almost immediately predicted what he called an era of abuse. He saw resistance coming.
And he was right, instantly. Resistance was documented as early as 1940 in E. coli, then in Staphylococcus aureus by 1942. Just a couple of years.
And today?
Today, it's a full-blown crisis. It's fueled by massive overuse. I mean, something like 30% of oral antibiotic prescriptions in the U.S. are considered medically unnecessary. That plus its widespread use in agriculture. Well, the cure is now fighting for its own survival.
Which brings us to today and what might be the ultimate accelerator of discovery itself, artificial intelligence. We've seen how these breakthroughs change the world, but AI is now making the process of discovery exponentially faster.
Yes, and that's happening because two big things came together. One, we now have these massive standardized databases of chemicals and materials. And two, we have the algorithmic progress, deep learning, graph neural networks.
So instead of a scientist just trying things out almost randomly, the AI can kind of skip a bunch of steps.
It can do more than that. It allows for what's called inverse materials design. You don't ask, what does this compound do? You tell the AI, I need a compound with these exact properties, high heat resistance, low toxicity, whatever. Now you go generate the recipe for me.
And that must have a huge impact on R&D, which can take decades. What are the sources saying about the actual efficiency boost?
They're very specific. A study on material science R&D showed that using AI tools boosted overall efficiency by about 13 to 15%. And this isn't just a small tweak. It led to a 39% jump in patent filings and a 17% rise in product prototypes.
That's a huge increase in output. But, the criticism is always about whether it's just doing more of the same, faster, or if it's truly radical innovation.
And that is the most important finding. Yes, it is encouraging radical innovation because AI doesn't have our human biases. We tend to explore things that are, chemically similar to what we already know. AI will generate things that are completely new, structurally distinct.
So it's finding things we would have missed.
Yes, the share of prototypes that represented entirely new product lines jumped by 22%. It is unlocking whole new areas of design that we just couldn't see before.
So looking back across this whole deep dive, from Gutenberg's press to the Haber-Bosch population boom to the speed of AI, the common thread seems so clear. The power of an invention is its ability to break a fundamental constraint.
Whether that constraint is the spread of information or the food supply, or now the very complexity of scientific discovery itself.
And we've also seen this other pattern, this immutable law that every single one of those breakthroughs, while solving one problem, immediately creates powerful, often delayed, and contradictory new challenges.
From religious wars to environmental collapse to antibiotic resistance, it's always there.
Which brings us to our final provocative thought for you. We've seen that the time lag between an invention, like Gutenberg's press or Haber's process, and its full negative consequences, the Reformation, the ecological crisis, that can be decades, even centuries. So given that AI is boosting radical R&D innovation by 13 to 15% right now, today, should we expect the unintended consequences of these new AI-driven discoveries to show up at an exponentially faster pace, leaving us far less time to even see them coming, let alone react? And that raises a really important question.